Good afternoon, everybody. I'm going to be talking a bit about Mike's research program that the Commission's run since I've been here, but a little introduction about myself, and we'll focus on one aspect of that program, on LIGUS, the research we've done the last 10, 11 years. One of you in the class has seen a lot of this information and been involved in some of it. Miriam in the corner there works in my program. So I may ask her to be quiet when I ask questions because you already know the answers to most of them. But actually I want to start with a question, maybe by hand. So it looks like there's about 20 people in here. How many of you have been on a strawberry grower's field, in a strawberry grower's field at some point in your life? Wow. Is that part of the class, or are you?
I'm impressed.
Yeah.
I do not think I did that in the hands.
That impressed me too. How many of you are getting degrees in agriculture, either undergraduate or graduate? So it's most of you, but not all of you. Yeah. How many of you are graduate students? So we have about 20% graduate students, 25% graduate students. Okay. All right. I'll start off. So I'm at the California Strawberry Commission. I'll tell you a little bit about the commission. It's actually a state agency, but we're not state employees. It was chartered by the state legislature back in '93. Before that, we were a board. You've heard of there's a number of commodity group boards, and the difference between a board and a commission can lobby. And they can also fund research at places like Cal Poly. Boards are required by state law to give their research funding first priority to the University of California. It was the way the charter for boards was written back in the 60s. And so usually those organizations work almost exclusively with the University of California, which is an outstanding research university, and it's a land grant at University for California. The commission, the CSC, is funded through assessments paid by the strawberry industry, and currently for those trays, a tray like that, the industry pays the commission 4.5 cents per tray. And that generates about $12 million a year, but it's all paid by the growers, the shippers and the processors. It's divided between the grower and the shipper, or the grower and the processor. They each pay half of that. We're managed by a board of directors, which is made up of the people who pay the assessments, growers, shippers, and processors. We actually have, most boards have about 8 or 10 people. We have 38 people on our board, so it's a really big board, and it's dominated by growers. I think 3/4 of the board are growers, so it's a really grower-driven organization. So the shippers obviously play an important role. And there's a handful of really big shippers like Driscoll, Nature Ripe, Wellpick, Central West. They're all important members of the organization, and they're all very active with it. And the commission was created, and it's really the focus. What we do now is work on issues management, like regulatory restrictions, whether it be on pesticides or on worker safety or on land use and water, marketing, promoting California strawberries, and you may see some of those ads on local markets because there's a push for marketing, especially in LA. And then also research and education, which is a group I'm in charge of, which is my primary responsibility. Who am I? I'm not a native Coloradoan. I grew up in Denver. I was born in Wisconsin, and one of the great jokes is you escape Wisconsin. There was a bumper sticker that said "Escape to Wisconsin," and most people cut out the "to," escape Wisconsin, but because the winters are pretty tough in Wisconsin. I hope nobody hears from Wisconsin. I'm not putting it down. But I got my 3 degrees in pathology at Colorado State University, which is in Fort Collins. It's the original CSU. There's a CSU here, obviously, California State Universities, but and then Cornell University, which is in upstate New York in a town called Ithaca. Really beautiful place. I got into plant pathology in a really unusual circumstance when I was a freshman at Colorado State. I was in the biological sciences. I didn't know what I wanted to do, and they had a freshman orientation like before classes start, and it was a huge auditorium. Colorado State's a fairly large university. I think at that time there was 18,000 undergraduates, and the auditorium held like 400 people, and they were all packed in there. And it was actually the catch-all. CSU is a vet school, so everyone who wanted to be a vet who didn't get into vet school was in biological sciences. And so they're going through and they're assigning advisors, and they asked first, how many of you want to be in zoological concentration in biological sciences? And everyone raised their hand because they all wanted to be vets, most of them. And I looked around and I said, I'll never get a job if I go in zoology. So I raised my hand with about 15 other people for botany afterwards, and that got me into the botany area, which is plant pathologies and botany. And then I did a work study job. I don't know if they have work study here or not. It's a form of financial aid, and basically you can do jobs and they pay you. It pays for a job, so people will hire you as a work study student anywhere. And I worked for a mycologist, a guy who works on fungi, and it was really cool, very cool guy, Brent Reeves, and very exciting, and that hooked me on being in plant pathology. And I switched to plant pathology, and then after getting my bachelor's degree, I took a part-time job working for weeding a bean field for a bean pathologist. So I had 30 hours a week, and this was back in the early 80s. There weren't any jobs, and the only job I could get was to go out and weed this guy's field with my bachelor's degree for an entire summer. But the good news of that was after I was through with that, he hired me as a technician, and then after a year as a technician, he said, do you want to be my grad student? I said, absolutely. And I entered grad school, and then eventually here I am. After I got my degrees, I did a postdoc in England for a year, which is interesting but different. It was a good experience, and then went back to Cornell. And then I got hired as a strawberry pathologist for the University of Florida, which was really a neat job at a small research center. I worked there for 7 years, and then got recruited to take this job in 2002, and I've been here 20 years. Come November 1, it'll be 20 years, and I'm as a director, and eventually got promoted into VP of Research and Education. So how do you guys know how agriculture research is funded, right? And this chart kind of shows what's happened over since 1970. This isn't billions of dollars in funding. And the top green line is private funding, and the solid blue is public funding like USDA and universities. And the two bottom lines below are the food manufacturing and agriculture inputs, and the orange line is the agricultural input, private ag, which is kind of like the commission and which companies like Driscoll do. And you can see that about 10 years ago, we passed the level of public funding. And public funding has been pretty flat. But you can see private funding's been increasing in the last 15, 20 years. And that's appropriate. I mean, it's really been a change where industries need to fund their own research in agriculture if they want to get the work done. And as the needs increase, there's increasing need for funding for it. And that's the commission's doing the same thing. They've been increasing their level of funding for research since I've been at the commission. Explain the difference between what the research the university does and what we do, the commission do. There's a lot of similarities, but I wanted to show you some of the difference and kind of emphasize that this is researcher focused. The research that universities and the USDA do, and that's the main groups that the state land grant universities like UC Davis and Riverside and those places, along with the USDA, do a lion's share of the ag research that's the public funded. Basically, they hire research with an expertise in a specialty like entomology or plant pathology, and then they survey the industry about what their research priorities are for the industry. or they may review reports on those priorities. So the USDA does some general reports. Actually, Gerald wrote up a report for strawberries, and they look at that and say, okay, this is what the industry says needs to be done. That's what we'll work on. I guess I have a question for you. I'm kind of curious what you think. How do you think a researcher decides what to work on? So how do you think Gerald, as a university researcher, he's somewhere between the two, how do you think he decides what research to do? Or any of these, or Shashika, or any of these guys? Do you have any guess how they might do it?
Whatever gets them published.
What's that?
Whatever gets them published.
Whatever they can publish. I think that's definitely one of the, that's absolutely, yeah.
Projects with grants attached to them.
Wherever they can get money from. Yeah, that's the other main thing. If you can't get money to do it, you can't afford to hire students and pay the research funds for it. And yeah, I think any other guesses or things? I think that was probably, Gerald, do you have any, what do you work on? I mean, what drives your desire to work when you were?
I try to find out what the industry needs are and then work on those things. And hopefully find a way to make money, or not to make money, but fund the work, and then to be able to publish the work if it's good science.
Fund and publish and needs. So, basically, I think, when I was at university, and this is part of it too, that you work on what you want to work on, right? That you're interested in. It's hard to work on stuff you're not interested in. So they identify research topics that the researcher really wants to work on, that he's either as experienced as to, or it's really interesting question, or it's a big problem, but you got to have some interest in it. I worked on above ground stuff like botrytis on strawberry. I didn't work on roots. I didn't like digging up plants. It's really hard to work on those problems because you have to kill the plant to look at it. So, and I shouldn't be telling that to some. I think there's a couple of grad students in here working on soil-borne diseases. But they're really hard to work on because, yeah, you literally can't look at it and go, I'll come back next week and see how it's progressing. You pulled it out of the ground and you probably killed it. So, and I like annual crops. Perennial crops, it takes years to grow your crop up. I mean, at trees, it takes 5 years for an orchard to come in production. So, and really, you have to get money to do it. So that's a really important aspect of it. And that usually what most universities, is, can I get the money and is it interesting? And then you conduct the research. You have to repeat it for several years to get enough. Usually you have to have 2 or 3 years to get, if it's certainly field work, so you can publish it in a referee journal and then publish the results of the research. And the publication is really important because at a university and the USDA, that's how they measure your success. Basically, they count the number of publications you have. And if you have twice as many as the other guy, they think you're twice as good as that guy. Flat, basically simple. And they call it publish or perish. I'm sure you may have heard that. And then at the end of it all, you try to extend your results of research to the industry. But that's kind of, it may be apply, it may not. It depends on your position. If you're extension position, it's kind of important to extend it, but it's not a high priority of a university. And so you can see I call that researcher focused, and I'm sure if a USDA guy was up here, he might say it a little bit differently than I did. But this is kind of essentially way I operate at the University of Florida. So the California Strawberry Commission research really is grower focused, kind of like Gerald said. We start by directly surveying growers about their production problems. And we do a lot of surveys, oftentimes when we don't know, we're trying to figure out what to work on a certain issue, we'll survey the growers to see what they're doing on it. And part of that reason is to identify the research that growers will support and fund. There's a lot of stuff I've seen, and Gerald's gone through this with my board. This would be really neat to work on. You present it to them, they go, nah, not interested in that. And guess what? You're not getting any money to work on it if the growers aren't interested. And we don't usually we don't go internally to do that research. We almost always start trying to get the university or the USDA to work on see if they'll work on the problem, because it's cheaper to have them do it. The university has a bunch of state money, and the USDA is funded by the feds. A lot of their overhead's already paid for, so it's a lot less expensive to have them do the work than to do it yourself. But if you can't get them to do the work, then you hire staff yourself, and that's what we did when we couldn't get research done on the problem I show you now. We hired a PhD entomologist ourselves to do the work. Our board told us to do that. And if that's not enough, you can set up a public research center, and that's what the Strawberry Center is. After about 7 years of us doing our own research, the board said, let's set up a research center, because that's actually gets access to students and the cachet of being part of a university system. And you got any guess why it's good to have research done by a university as opposed to a commodity group? Especially when it's like, when you're talking to regulators.
It's supposed to be unbiased.
Yeah, they view university research as unbiased, so they're not, whereas if the commission does it, they immediately think we're slanting it to support the strawberry industry. If Gerald does it with our money, they feel he's not going to slant it as much. And I'm not sure if he is. You better not. I hope he does slant it our way more than, but yeah. So there's a certain inherent value to that. So the center really was created to help have that link to a university, access to students, and train people. I mean, the commission, we've hired. I'm trying to think we have currently. How many Cal Poly grads working for us? 4 or 5, I think. So before, we didn't have any. Before the Strawberry Center, we didn't have a single Cal Poly grad working for us. And so it's really a nice training vehicle to get into the industry. And I know there's a lot of people who've been placed in the industry from the Strawberry Center. So after we do the research, we then extend the results to the industry and evaluate the adoption. And that's an important part of it. Success for us is measured by adoption of the results in the industry, because we're trying to solve a problem, and if they don't use it, it hasn't solved that problem. And so quite often it's not successful, and then we do the step that's not typically done at the university. If it's not, we go back and try again until we solve the problem, or we decide we can't solve the problem. So we'll modify it and go back and do more research and continue to look at it to try to solve the problem. And a lot of the difficult problems aren't easy to solve. I mean, there's a reason there are problems. If they're easy, they would already been fixed. So since I've been at the commission, we've worked on at least 6 big research areas. First one was methylbromide alternatives. And that was because they're phasing out methylbromide because it's an ozone depleter, right? Created the ozone hole in Antarctica. And it was going to get phased out. And we did a lot of research to try to find alternatives for it. That wasn't very successful. In reality, now the only fumigants that are still used are chlorpicrin and talone, and that are somewhat effective. And those were developed in the 60s, the same time methylbromide. So that wasn't a successful thing. Then after about 5 years, we switched to fumigant emission reduction to preserve the use of fumigants, because we knew we were going to lose methylbromide, and we were going to also lose the rest of the fumigants because they're pretty toxic, right? They kill everything, and they use hundreds of pounds per acre. And so we spent a lot of time, we're the first organization to do that, using these barrier films, TIF and VIF, that basically trap the fumigant in the soil until it breaks down, so it doesn't off-gas and create a risk to neighbors or workers. And that's been really successful. Most of the regulators are not really concerned about emissions from fumigants anymore. There's some concern about that, obviously, and it's probably not going to preserve them forever, but it certainly has lowered the concern of the regulators because they're very effective at reducing off-gassing and emissions and reducing accidents. The other area we worked on after we did that was substrate production, because we wanted to see if we didn't have fumigants, can we grow in substrate? And so growing in peat and core and stuff. We spent about 5 years with that. It's very expensive. There are some guys doing it in different areas, especially in Santa Maria. I don't know, there may even almost be close to 500 to 1,000 acres of it now, but it's quite an expensive system. If you don't have fumigants, it's probably going to be really practical. So we didn't convert the industry to it, but we showed them the possibilities for that. One of the things we also did was develop a food safety training program. I think everyone sees that leafy greens, probably you see almost once or twice a year there's a recall of lettuce in the news. That happens all the time. There was a recall of spinach back in 2005 that shut down spinach production. Basically, the FDA told people don't eat spinach, fresh spinach. And so everyone who's growing spinach that had to harvest it in the 3 weeks that they were told them not to eat spinach had to plow their fields under. The field that the outbreak occurred on was next to strawberry fields up in the Watsonville area, and it actually was a field that had rotated with strawberries. So the strawberry growers were really beside themselves, because if you can't sell strawberry fruit for 3 or 4 weeks, you have to keep harvesting, otherwise the whole crop just rots in the plant and you can't recover it. So they would have just bankrupted all these farms because they couldn't have paid to do a month of harvesting without getting any money back for the fruit. So they were just in a panic, and so we did a training program to make sure that wouldn't happen to us, and it focuses on harvest workers, and that makes sure they're aware of the risks and follow certain procedures. And it's been really successful. We got 90% of the industry supervisors have been trained in that program, which is a really high uptake in any research program or a training program. We've also done a sprayer maintenance and calibration program that I think, again, 90% of the industry, we've reached out and do very hands-on with them. It's really a marriage between our research program and our education program, which work very closely together. And spent a lot of time working with growers, and that's a very successful program. And then the one I'm going to talk about today is control of lygus bug. And lygus is a nasty bug, and let me talk about that program. So lygus is important because it causes what's called cat facing, deforms the fruit. And it feeds on the achenes, and as the fruit expands, that dead achene causes the fruit doesn't expand right around it, and it deforms it, and you can't market that fruit. It has a very low threshold. You only need 1 lygus per 20 plants, as determined by beatboxing, a sampling procedure, which gets about half the lygus in the plant. So it's really 1 lygus per 10 plants. If you do the math, that's only like 1,000 lygus bugs in an acre strawberry field, 2,000. It's very low population. You'll get significant losses. We estimate it's over $100 million a year lost to lygus in the industry right now. What happened was that Dow Chemical withdrew the label for Lanate on strawberries, and Lanate was pretty broad spectrum and not a very ecologically safe product, but they just withdrew it from strawberries, and within 2 years lygus was the #1 pest on strawberries because it was used and very effective against it. We're not going to get it back. We tried to get the university to work on it. They weren't interested in working on it at that time. They'd already done the work, they thought, and so they did some work, but they weren't able to solve the problems. So we started our own programs, hired an entomologist in 2011, and it's actually still going on now. And I'm going to talk about that now. So here's some pictures of lygus, the small, mid, and large, and adult nymphs. There's actually, I think, 4 or 5 instars, but that's what they look like in the field. And if you go to Santa Maria, you'll see them in every field. And you'll see obscenely high numbers in some fields, and you'll see lots of cat-faced fruit. We were just out at the Strawberry Center field, and I was amazed because I was looking at all this fruit on the plants, and not a single fruit was cat-faced. I was really taken aback, and the reason is because they don't have Lygus in that field. And so it's pretty dramatic what happens, very damaging pest. And so what started this, the first thing we decided to do is look at what's called the Degree Day program and use that to target the use of a new product that was called Ryman. It was being introduced, but it's an insect growth regulator, which means it stopped the molting of the instars so they couldn't become adults and lay eggs. But it doesn't do anything against adults. So you don't want to spray adults, you want to catch the hatch. And the researcher at Davis, who's a very good researcher, they recommended we monitor fields, find out when the first Lygus gets in the field, and then figure out when the hatch would occur. Basically, you predict when the eggs would hatch, and then you can time the sprays. So it's very IPM. And kind of the details of how you do that, you just take the average high and low temperature. You take the average between the high and low each day and subtract the number that's been calculated, and you keep a running total. And after 252 degree days, eggs hatch after the time they're laid, which is when you assume after your first Lygus is spotted. We decided to see if we could get growers to do that themselves, make it work, because it had been reported on for 2 or 3 years and no one was using it. So we trained a bunch of growers to scout for Lygus and determine when they first appeared. And then we installed these degree day weather stations next to their field to count the degree days. And then they could watch them and monitor, and we could see if the hatch would occur at the time the degree day said it would, at 254 degree days. Well, what happened was not what we expected. This is a bad result. The degree day predictions missed the target hatch. They were 42 days late. And here's a picture. So on the left is the number of Lygus for beet box sampling, 0 up to 60 there. And the dates on the bottom, you can see we're at the 18th now. Very low populations now, and this field was, I think this was in Santa Maria. And here's the sprays that were applied in this particular field. And the degree day prediction was on around July 8th, July 14th is when the degree day would be. And we missed it obviously by quite a period there. In fact, every field we were in, we had the PCA call us and say we're already seeing Lygus and the degree day hasn't come up. So we didn't have a single field where we hit it right using this method. We don't think it was a problem with the method. It's just that the level of scouting that most growers are able to do, they didn't catch the first Lygus coming in the field. And they would catch it 2-3 weeks later probably. The other thing probably too is that the temperature of the edge of the field doesn't match what's on the bed. And there's a reason growers put dark plastic out, because it heats the bed up and the plants grow faster in the winter. And since they plant in the fall and grow the strawberries in the winter, it's quite a bit warmer. And so we underestimated the degree days by putting the weather station outside the field. You can't put it in the field. You could, but the tractors break them off, because tractor going over every acre of the strawberry field once or twice a week, when we put those things in the fields, they get broken off by the tractor catching them. Even if you put flags on them, it's just hard for the operators to avoid them. You end up breaking them. So we weren't able to set them up in the field. But from it, the entomologists we had said, well, this is ridiculous. Why are we waiting for degree day? Why don't you just monitor? And when you see the hatch in the field, you start spraying. And she was right. We don't need degree day monitoring. If you're out there monitoring, which is good IPM, you can just see it. So the next year, 2012, we created a Lygus monitoring program to catch the first hatch. We trained irrigators. So every grower has an irrigator in his farm. He's walking around irrigating and often has a lot of time on his hands. And we taught 21 of them, actually we taught more than that, but 21 of them did the whole season how to scout. And we went out every week, and they all learned how to scout and detect the pathogen, detect the pests and the beneficials, and count Lygus. And through this, we were able to then time the sprays for Ryman based on when the hatch occurred in the field. We also compared fields back at this time 10 years ago, there's a lot of growers doing second year fields, and I don't know if you know what a second year field is. Where, since strawberries are annual, most growers pull them out and then they come back in a different crop. In this area, they don't plant in the same ground because the crops overlap oftentimes. But a second year field, guys who have may not have made a lot of money and they don't have the shippers supporting them for a second year, keep that crop in, mow it down, and harvest it for a second year. And you can imagine it has all the insect and disease pests already in there, so there's a big pest population in that field. And if you grow next to that field, there may be a risk that they're moving into your field earlier. So we wanted to see the impact of second year fields, and there were a lot of them in Santa Maria at that time. We did both of those approaches. And this is a very scary picture for the Lygus population. So the dashed line at the bottom is the threshold when you should be trying to control the pest or damage occurs. And I'll show you another picture that actually quite a bit of damage occurs there. There were 14 sprays during the season that he applied, and he probably applied more because he kept harvesting after then, but you can imagine how much Lygus are in the field. There's literally, the blue is the adults, the red is the large nymphs, and the green is the small nymphs. The populations just blew up. And here we have Ryman, you see being sprayed at the right time early. They caught a hatch and they sprayed it early. It seems to keep it from blowing up for about a month, and then a second application, but by then it had taken off and there was nothing he could do to knock that population back down below threshold. This isn't what every field looked like, but this was actually a common occurrence we saw with this field. This was one of the worst fields, and really substantial losses. And it was adjacent to a second year field, and then there's no vacuums being used in the second year field. And I'll talk about Lygus vacuums in a second. Here's another example of a field where a Lygus vacuum was used in the field twice a week. This was up in Watsonville where Lygus vacuums were developed and they were used commonly. It was next to a second year field. And here you can see that the vacuum appeared. It didn't stop the small nymphs from developing, and the sprays are those arrows on there. We still had large nymphs, but the adults and large nymphs populations were kept relatively low compared to that other field. And you can see the vacuum appeared to really control the adults and large nymphs. It didn't do a very good job in the small nymphs. And we concluded that the populations really aren't controlled, and that was the case in most fields. Growers weren't controlling Lygus. And the second year field was an important source of Lygus, we decided. So we thought we got to talk about second year fields with the growers, and we got to look at vacuums. One of the things you see, and during that year we also looked at insecticide resistance. So you see all those insecticides being used, why aren't they working? And so we tested a number of fields. And the way you do this bioassay with Lygus, at least the way we did it, is you take the full rate and you pipette it on top of the Lygus, and they dose them completely, the adult, and then drain it and dry it out. So they got perfect application of the top labeled rate of the product drenched on them. And here is the results of that for a common product called malathion. Typically you want over 70% kill to be that there's no resistance. Only 2 fields did we find that, and this was 21 fields. You get slight case of resistance at 50% to 70%, and if it's below 50%, there's resistance. You've given a perfect dose and you didn't kill it. We saw almost all the fields, malathion didn't work. It was not an effective product. And that was the case for most of the products we looked at. The insecticides are just not effective anymore with Lygus because they've been exposed for so many years to it. We also looked at a tank mix of malathion with Actera, which is a neonicotinoid, and we got a different result. And the tank mix was very effective. And you can see almost all the fields were highly effective except for a couple where there's some resistance. This was 10 years ago. I don't think it's the same situation now because it's been used extensively by growers, but it's a difficult bug to control, primarily because there aren't a lot of options for insecticide control. So basically, we concluded that Ryman wouldn't be sufficient. The degree day model or timing, it just didn't. As you could see in that one example, the field going up, it gave a slight suppression, but it wasn't enough to stop it from blowing up. Second year fields were an important source, and the Ligus vacuums were effective for killing large Ligus in adults, large nymphs in adults. And really, these things were quickly adopted by the industry. Many growers in Santa Maria bought vacuums in the 2013 season, and now about 80% or 90% of the growers use vacuums. Before that, they didn't use vacuums at all, hardly. Only about 20% had them. And second year fields, basically, any of the landowners won't allow second year strawberry production. There still is some, but it's almost none anymore. So the result of this research literally led within 1 or 2 years to a major change in behavior in the industry, an attempt to try to improve the control of Ligus. Let me see that. So we decided to focus on the Ligus vacuum. How many of you have seen a Ligus vacuum in the field? Probably the big yellow hoods on them out there. They're all over Santa Maria now, and they're quite common in all the production areas, actually. Most growers who have any Ligus have a vacuum, not all. We didn't know if there were differences between the vacuums. So we decided to evaluate the performance of the vacuums to see how well they are working. Most of them look like this because they're made by one company, but there's 2 or 3 companies that make vacuums, fabrication companies, local ones. And we conducted experiments to see whether there's differences in Ligus between vacuum and unvacuumed sections in the field. And then we also looked to see how much Ligus populations were related to cap facing. And this was all done. As you can see, 2013, we started 2 years ago. We've gone through we rapidly changed our program. As we got a result, we don't go back and repeat it. We move on and there's a rapid change because the industry is losing $100 million a year. They can't wait for us to spend 5 years looking at resistance bioassays and declare, oh yeah, none of your insecticides work. We quickly saw that insecticides would not be the solution for them, so we focused on the vacuum. We changed our effort towards that. This was an example of the vacuum exclusion experiment. We couldn't get growers to leave whole blocks out, but we got them to, in a number of fields in both Watsonville and Santa Maria, leave 6 rows, which was 2 passes, 6 or 8 rows, depending on the number of hoods in the vacuum. 2 passes of the vacuum. We flagged it off, and the rest of the field was vacuumed. They're vacuuming twice a week the entire field, but except for these 6 or 8 rows in the middle. 6 rows in Santa Maria. And we monitored Ligus in there weekly, and then we evaluated fruit damage after 6 to 8 weeks. And here's what we found. These bars are the number of Ligus we saw in the field at the different fields, the 13 fields we were monitoring with that. The vacuum block is the blue or purple. And you can see there is a dramatic reduction, 40% less Ligus in the vacuum areas than the non-vacuum areas. So it was obvious that the vacuums are effective at reducing the population of Ligus in the fields. Dramatically so. And here's the numbers when we broke it out. In the second year, actually we did 2 years. The second year, the second year means we actually did this study in a set of second year fields that grower had come in because we knew they'd have high Ligus populations, and they're one of the first adopters of vacuums. And you can see the adults, large nymphs, small nymphs, and you can see that the adults, essentially almost no adults were found in the vacuum fields versus non-vacuum, and the reduction in both large and small nymphs. And then now to cap-faced fruit, we had significantly more cap-faced fruit in the non-vacuumed areas in both downwind and upwind. And the downwind was just on the east side versus the west side. In Santa Maria, the wind blows almost always from the ocean. We just looked at each side to see if there was an effective wind, because the Ligus might move with the wind more, and there really wasn't. But from this, we were convinced vacuums were an important tool, probably a better tool than insecticides for controlling Ligus. This is a study where we took Ligus. On the graph, we have the number of fruit damaged by Lygus, cap-faced fruit, versus the number of Lygus per 20 plants from the beet box sampling. We took it 3 weeks, the count from 3 weeks before fruit evaluation. Does anybody know why we would do the count 3 weeks earlier than when we evaluated the fruit? We didn't do it at the time we were evaluating the fruit. We took the sampling from 3 weeks prior to the fruit evaluations. Anybody have a guess why we would take the counts from 3 weeks before? Because that's when the Lygus are feeding on the achenes. Oh, I'm sorry. Did I miss? That's when the damage is occurring and it doesn't show up for 3 weeks in the field, 3 or 4 weeks. I'm sorry, I didn't see. Stole your thunder. But and here's a graph of the intersection. So there's the threshold, the published threshold that says control Lygus above this. Here's where even we had no Lygus, we saw damage between 10 and 20%. That suggests the threshold is probably lower than 1. And when we talked to the researcher who created the threshold, he said, yeah, it's probably 1 per 100 plants. But no one did actually do sampling that way, so we said 1 per 20 plants because you could actually do the sampling then, because no one's going to beet box 100 plants. And then when you look at the threshold, we're looking at 15 to 25% damage. So it's a hugely it's probably the most, can't imagine a more damaging insect out there in field. They just take one bite and they move around and bite another fruit and move around and bite another one. They just devastate a field very quickly. And most of the fields we looked at really lost control of Lygus during the season. I mean, if you have a Lygus problem, most likely you don't control it in California and strawberries. And that's the same today, even using vacuums. But you can reduce the level of damage with the vacuums. So we decided, for the assessments, we were looking at the performance of the vacuums, and this is really kind of surprising and interesting because no one had actually done this ever. They built these vacuums and did some research in the 90s, UC Davis, and then they started building vacuums and modifying them for 20 years, and no one went back and studied what they were doing. They just said, oh yeah, it sucks up Lygus and it must be working. And we said, well, let's go see how much Lygus it's sucking up. So we build these little catch nets and socks. The catch nets would catch them before they went into the vacuum, and we drop it in a box and count them, or after they pass through the vacuum in the sock. The before would be the live Lygus, and hopefully the after would be dead Lygus. Or we'd see how many were killed by the vacuum, the fan blade, chopping them up. And that's what they thought would happen. And then we also measured the operating parameters of the vacuum just to see how well they performed. And let me see, so the efficiency result, the assessments were, one of the real surprising things was, and here's an example of 8 vacuums in the adult Lygus, which were the easiest to kill. A couple of vacuums didn't even kill half the Lygus, so they sucked up, the Lygus they sucked up, they blew out the top and they're still alive. They weren't killing them. Which is just maddening. The poor guy with the first vacuum there was just giving amusement park rides to Lygus, it looks like.
And you got a question from that.
Yeah.
I'm actually wondering, I'm not sure if you mentioned it, but how do you count the Lygus?
So how do you count Lygus? There's a number of ways to do it, but the way we did it was you take like a shoe box, has a lid, one of those clear shoe, it's about I don't know, about this size, and you take the lid and you hit the plant and knock the Lygus off the plant into the shoe box, and you walk along and you put the lid back on until you get to another plant and knock it so it doesn't fly out, and you do 20 plants that way, and then you count how many are in there. And the research has shown that if you do it properly, you get about half the Lygus in the field. You can knock them off by doing the beat boxing like that. And so that's how, and then you can estimate the actual population of the Lygus in the field and the effect of and after you do a treatment, a spray or a vacuum, you can go back in and do the same thing and see the reduction, and you decide how much you've controlled it. We found the average wind speed, these are vacuums, is how fast they're sucking probably impacts whether you take it off, like your carpet, if you're vacuuming, if it's not got a lot of suction, you're not going to get much dirt up. It's the same with that. We found the speed was probably 29 miles an hour, but there's a huge variation. And the most disturbing thing was that over half the small nymphs and, almost a third of large nymphs and 20% on average adults weren't killed by the vacuums. And it's like, that's really frustrating. They go all this work to suck up a few ligas and they don't kill them. So we decided to go back and really try to look at different key areas of the vacuum to see if we couldn't improve performance of it. And we looked at these areas, tractor speed, and it's really jumping ahead here. Well, we'll keep going then. Maybe I'll go back one. So we looked at tractor speed, how fast it's moving through the field, the airspeed of the vacuum, the type of deflector plates. People put these deflector plates on so they felt the bug would hit the deflector plate and die. But they also affects they're called baffles. The height, they run above the canopy and reducing the size of the front opening to see if that would improve the airflow. And we found that baffle design was really an important element. So a lot of growers had baffles like the ones on the left there, the old style 45. That kept the suction going, but the bugs would pass through alive, a lot of them. It wouldn't kill any of the bugs. And if you use a 20-degree baffle without holes in it, it would kill them, but it reduced the airspeed enough so it wouldn't suck up any. We figured out, some guy recommended this, we tried these, what's called a punch plate, and put it on there. We were able to increase the airspeed from 30 miles an hour to 47 miles an hour using 20-degree baffles like that. And that resulted in killing most of the ligas that entered it. The fan apparently doesn't kill a lot. It's the impact on that baffle that crushes the ligas. And sorry if you're squeamy about crushed ligas, but growers like to see crushed ligas for obvious reasons. We also decided, you can see there's this big front opening that was kind of built by the growers asked the manufacturers, I go in the field and it dips and I don't want to dig the plants, so can you lift up that opening so I can go in? And so they redesigned it to do this, and we looked at it and said, how much air is coming in there? So we strapped on a thing on the front, and basically we doubled the uptake of ligas from just doing that one front plate on it. The real neat thing about this is you can tell if a grower has his vacuum set up properly with a front plate. You can see it from the highway that he's got a front plate on there. But if he has this old style vacuum, you can see on this graph the number of ligas per sample. No front plate, the black, and with the front plate, it's more than double adults, large nymphs, but the really surprising thing was the small nymphs. We're now, with this front plate on and the other changes, we're able to suck up small nymphs. Before, the vacuums really didn't get small nymphs at all. We'd only see large nymphs in adults with the vacuum. So we were able to improve the vacuum, and I think we were able to dramatically improve the vacuum. The original vacuums got about 2% of the ligas out of the field. It makes you think, how did they have any impact? But even with those ones that are getting 2 to 4% of the ligas, we were seeing a reduction in half the damage in the field with those. So we were able to increase it to about 14 or 15% of the ligas in the field being sucked up with that. But we kind of run out of resources for, as biologists, we're entomologists and I'm a plant pathologist, we can't redesign the vacuum. We don't know what motor to put into it and how to make it work. So luckily we had engineers. We brought in the big guns, the engineers. Are any of you guys engineers in here? Yeah, I don't understand them either, but they're really neat, but they're a little geeky. But we did this research at the Cal Poly Strawberry Center, and this John Lynn, who actually will be the next speaker, I guess, will come and talk. Hopefully he doesn't talk about vacuums too much, but if he does, you can surprise him with how much you know about them. And they redesigned the vacuum with the goal of improving performance, because as we've seen, chemicals weren't working. The vacuum was effective at reducing, but there's still lots of damage occurring. So we decided to focus on the vacuum. This is 2017, so we're already 6 years into the program. And this is a video that the engineers, first thing they did was put the vacuum over some strings to see how it was sucking. Very simple, something we never did. And you can see in the ads, the strings are actually laying down and blowing sideways. So that's the width of a strawberry bed. And basically what they could see was that the vacuum was basically vacuuming in a 4-row bed, the center 2 rows. And the outer 2 rows, it wasn't pulling any ligas off, or almost none. So it wasn't a very efficient design. They did some modeling, as engineers like to do. They always have these cool videos to show. And they saw the same thing in the model. Because of that narrow opening, the ligas, and this is one where they put a front plate in the model one, you could see these simulated ligas are sucked up, but only from the middle, and a lot of them fall to the side and aren't sucked up. So they knew they had to go in and redesign the vacuum. When you see the early prototypes, what the engineers come up with, you won't think they're crazy. And here's some of the prototypes. And that's Jack Wells, who was a Cal Poly graduate who worked with us for a couple years in the vacuum and still working with us as a consultant. This was his development, was a double barrel vacuum with 2 barrels instead of 1 over the bed, and had some wheels which didn't work, and we got rid of those. They thought they could wheel it through the field. The furrows are too messed up to be able to, yeah.
Technically, I'm not a student, but I'm learning. So with all the force that's pulling the ligas into the machinery, what about plant damage or fruit damage?
Yeah.
It's not at the point of fruiting, or what the plant damage?
That's a good question. And people say, well, you're sucking it so hard, aren't you hurting the flowers? And maybe that's causing cat facing, the vacuuming. You're damaging the fruit. We haven't seen any indication of that. In fact, if I go back to the earlier vacuum designs, you could see the cat facing drop dramatically in the areas that were vacuumed. And the same thing we're seeing when we've done research with the newer vacuum. And the fact is it's only over that plant for about 2 or 3 seconds. So it's a very short burst of wind. I mean, if you're in Santa Maria, it's 20-mile-an-hour winds most days. So they're already being blown around a lot, but it's something we were concerned about, but we haven't seen indication that it's damaging the plant. But so this is a prototype. The growers kind of laughed when they first saw it. It was a bit of a monstrosity, but by going through this prototyping process, they were able to come up with this new design. And I don't know if anybody's seen any of these in the field. These are now out in the fields. And about 20% of the industry is bought. There's about 20 of these bought now, and there's going to be more in there. But they have 2 vacuums per bed. And they move the fan to the center of that column, and it's a big open column. And it's much more efficient. In fact, it doubled the performance of everything we did to improve performance. It raised it from about 15 to 30. Well, actually, I'll show you the numbers for it. Actually, I'll show you a picture of what it does. So on the bottom, you have the old vacuum. You can see how it's teasing the plant up. No, I didn't want that to happen that way. Maybe I waited too long for it. Let me go back one more. There, and the up top is the new vacuum. You can see how it's actually lifting the fruit up. It's just dramatic how much more force that's applying. And you can imagine how much more ligas is sucked up. It's just fantastic vacuum. And with that vacuum, we see anywhere from 20 to 35% of the ligas removed from the plant. So it's a dramatic improvement. They've only been around being manufactured for 1 year, so it's not enough in the industry for us to see. But it removes, he says, 2.3 times the regular vacuum. There's also done a version of this for the 2-row beds up in Watsonville called the single barrel vacuum. I prefer, there's 6 of those, there's 3 sets of those double barrels. I would prefer they call it the 6-pack, but they went with the double barrel. I didn't get to name it. And so these are the results of 2 of the studies we did, the grower standard, the optimized one that the biologists were able to optimize to 13 and 10%, and they got 28 to 33%. So really dramatic, significantly greater vacuuming of it. So that's the next step for us is a training program. And so right now we're developing a training program. The final piece we know the industry's adopted these things. We'll see if they adopt the double barrel. But the growers don't necessarily know how to use it, optimize, or have it set up the proper way, making sure they're running at the right speed, they have the right air speed. They all change things around because there's no training. So we're developing an extensive training program, much like we've done with sprayer calibration and food safety. And we'll be doing a bunch of training probably the next year as we get it rolled out. And hopefully we'll see an impact on the amount of damage caused by ligas through the program. But so that's the Commission's research approach, kind of a rapidly changing target until we get to something we think will help the industry and really move the needle. And that's the end. That's all I got.
Thank you, Dan, for a look at just a piece of what you've done over the course of your career. Any other questions for Dan before we call it a day? You didn't get answered? I know there was a lot of material to go through. I was,
Yu-Chen has a question.
Yu-Chen? Sorry.
So you mentioned that the private industry is having like dramatic amount of funds compared to the public. And do you think that's going to be an issue if there's a gap between the private industry technology compared to the public? Or what kind of issue will happen?
Well, I think that, I think the industry should fund research, right? I think in the past they said, well, the government will pay for it and they'll do it for free for us. And I think now it's got to the point, it's like a $3 billion industry. They can certainly afford to do research. And the big shippers already do. I mean, Driscoll has a huge research program. NatureRipe has a research program. They all do their research on their farms to a certain extent, but I think the industry just needs to step up and do the research themselves for it and can do more relevant, like this, can focus on an issue until they find a solution that, I'm not sure if a university had done this program that they would be at the same place we are, where we have an improved vacuum. I don't think that would have happened at a university-based research program because of the need to get engineers involved and the tight feedback with the growers.
Did that answer your question?
I think she was asking about privatization of research and it being public.
Oh, so I didn't hear you properly.
Yeah.
Well, everything we do is public. So like that vacuum, that's open source. So everything that the Commission does, the private is, but yeah, companies like, they may keep some of that research private, but that's why an organization like the Commission is important, because we do a lot of the work that the individual shippers won't do because they benefit more than just them. So yeah, I mean, we see that like with the robotic harvesting, and John will probably talk about that in the next class, that they're all proprietarily developing and keeping patents on it, and they're not sharing, and they're stuck. Everyone has to reinvent the wheel 8 times to try to figure out how to harvest strawberries. So yeah, I think there is a problem there, but there's maybe a way around it for like Strawberry Center and the industry taking on a holistic approach and everyone working together to solve the problem.
Other questions? I remember you saying something about substrate production. Wondered if everybody understands what is meant by substrate production. I see a few heads nodding, but maybe you could explain briefly what...
They also call it hydroponic. So it's not with soil, but with coconut coir peat. So if you've ever seen these peat bags, they grow in trays, and they pour peat and coconut coir in, so it doesn't have any. So there's no pathogens in there. It's sterile media. It's not sterile, but it doesn't have any pathogens because strawberries haven't seen it before when you start with it, and so you don't need to fumigate. Mainly it was developed to avoid the need to fumigate, and then you throw it out at the end of the season, throw it into a field, so there's no waste, and then you bring back a new batch in, so you can avoid the need for fumigation by doing that.
So that's practiced in various places in the world, and there is some also here, and it is a way of obviously eliminating soil-borne pathogens. Soil-borne pathogens are one of the biggest problems we have. Anything else? You should, okay, so that's it. Thank you, everybody. Make sure